Dear students, I hope you have well understood the previous lectures of the same chapter, chapter number 1, that is rational numbers. Now, in this lecture number 3 of mathematics class 8, we shall review the process of representing rational numbers on the number line. Now, as I told you that you have already learned this concept in your previous class, so let us have a basic idea first and then we shall review more about this concept. Now, to represent rational numbers on a number line, we proceed as under. We first of all, it is it is well known to everyone that first of all, to make a number line we need to draw a straight line and we need to mark arrows on both the sides to show that line continues indefinitely in both the directions. Now in the center of this line we mark a point 0 and label it as 0. It represents definitely 0. Now after that we select a unit of length and mark points on both the sides of 0. Now the points which are on the right of 0 are positive and the points to the left of 0 are taken as negative. This I think everyone knows how to make a number line. So this is the basic number line, but here in this case I have tried to show you the rational numbers between one particular unit of a number line. For example, between 0 and 1, that is 3 by 3 is equal to 1. So between 0 and 1, I tried to show you two rational numbers, that is 1 by 3 and 2 by 3. Same is the case between 1 and 2. In this unit, I have tried to show you the rational numbers between these two units, that is 1 and 2. Likewise, it will be 4 by 3, 5 by 3 and 6 by 3 definitely is 2. And if we have a look on the negative side of this 0, negative side of 0 or left hand side of 0, then I will find between 0 and minus 1, the rational numbers are minus 1 over 3 and minus 2 over 3. Between minus 1 and minus 2, the rational numbers are minus 4 over 3 and minus 5 over 3. Likewise, in between any two units on a number line, we can find indefinitely any n number of rational numbers. I hope this concept is clear to you. Now, using this concept, we will be now representing rational numbers on the number line. Now, the very first thing or the important thing which you should keep in your mind is, for any given rational number, the denominator tells the number of equal parts into which the first unit has to be divided, and numerator informs how many of these parts are to be considered. Okay, so for example, if I need to represent 4 by 9 on the number line, here the numerator, that is 4, will tell how many of these parts are to be considered. Out of 9 parts, I need to consider only 4 parts. So 9, that is the denominator, will tell you into how many number of equal parts I need to divide the first unit. For example, 4 by 9, so it will lie definitely between 0 and 1. So between 0 and 1, I need to divide this unit into 9 equal parts, and out of those 9 equal parts I need to consider the fourth part. So it will be 0, 1 over 9, 2 over 9, 3 over 9, 4 over 9, 5 over 9, 6 over 9, 7 over 9, 8 over 9, 9 over 9, that is equal to 1. And out of this, the point or the rational number which I need to consider is 4 over 9. So I will be marking it in circle like it is shown in the number on the number line here. Now, another example that can be taken as minus 5 over 6. Now, negative numbers are to be drawn on the left hand side of 0. So, it will definitely lie between 0 and minus 1. Same we have done it for the addition of positive rational number. Same is the case with the negative rational number. So between 0 and -1 we will divide it like this: -1 over 6, -2 over 6, -3 over 6, -4 over 6, -5 over 6, and -6 over 6, that is equal to -1. So the point which I need to consider is -5 over 6. So I will put it in a circle, that is -5 over 6. Now I hope you are well known, it is well known to you how to represent a rational number, whether it is positive or negative, on a number line. Now, next important concept is rational numbers between two given rational numbers. Now, if I need to find out n number of rational numbers between any two given rational numbers, then there are two methods to solve this. First one is, when given rational numbers, both the rational numbers are having the same denominators, then multiply the numerator and denominator of both the rational numbers by n plus 1. Suppose if I need to find out 5 rational numbers between any two rational numbers, then but the condition is if the denominators are same, then in that case I need to multiply it by 5 plus 1, that is 6, both numerator and denominator. Now, second case is when given rational numbers are having the different denominators. In that case, first of all, I need to take the LCM of the denominators. Then I need to change those rational numbers into equivalent rational numbers with the LCM as their common denominator, and then obviously after this step we will be able to get the n number of rational numbers. But if after that also I am not able to find out n rational numbers or the required number of rational numbers, then I need to multiply the numerator and denominator by each rational number by n plus 1, as we have done in the first case. Now, for example, we need to insert 5 rational numbers between 1 by 3 and 2 by 3. These rational numbers have same denominators, so it is an example of case 1 in which the denominators are same and we need to insert 5 rational numbers. So what do I need to do? I need to multiply both numerators and denominators by 5 plus 1, that is equal to 6, because 5 rational numbers are to be inserted. So 5 plus 1, that will be 6, and I need to multiply this rational number, that is 1 by 3, numerator and denominator by 6, that will be equal to 6 over 18, and same is the case with 2 over 3. So 2 over 3 is equal to 2 into 6, and denominator will also be multiplied by 6, so it will be 3 into 6, that will be equal to 12 over 18. So I am repeating it. If I need to find out 5 rational numbers between the rational numbers 1 by 3 and 2 by 3, in this case the denominators are same, so in this we need to multiply the numerator of one rational number, denominator of the same rational number, and numerator and denominator of the other rational number by 5 plus 1, that is equal to 6. So 1 by 3, that is equal to 1 into 6. Denominator is 3, so it will be multiplied by 6, so it will be 3 into 6, that will be 6 over 18, and 2 by 3, that will be equal to 2 into 6 over 3 into 6, that is 12 over 18. Now, after this, we will be able to easily find out the 5 rational numbers, that will be 7 over 18, 8 over 18, 9 over 18, 10 over 18, and 11 over 18. Now, the point here to note is, now we are supposed to find out the rational numbers between these two rational numbers, and if I have a look on the previous slide, I found that it will be 6 by 18. First rational number is equivalent to 6 by 18 and second rational number is equivalent to 12 over 18. So between these I need to find out the rational numbers. So the rational numbers will be 7 over 18, 8 over 18, 9 over 18, 10 over 18, and 11 over 18. In this case, 6 over 18 and 12 over 18 are not at all included, because I need to find out the rational numbers between these two rational numbers. So between these two rational numbers, that is 6 by 18 and 12 by 18, these 5 rational numbers lie. Now, I hope all these concepts of this chapter, now today we have studied about the representation of the rational numbers on the number line, how to find out n number of rational numbers between the given two rational numbers. So on the basis of that, I am assigning you the homework from NCERT book, exercise 1.1. Question exercise 1.1. In that exercise, we have revised the properties. We have done, this exercise is basically based on the properties of rational numbers, additive inverse, multiplicative inverse, and verification of the left hand side and right hand side. So on the basis of that, question number 8 and question number 9 are to be done in your homework notebook. Simple, in these two questions properties are to be used and you are supposed to solve it. Now from this exercise 1.2, in which we have the concepts which we will be using is based on the representation of the rational numbers on the number line, and how to find out n rational numbers between the two given rational numbers. So on the basis of these concepts which we have studied right now, it will be question number 1 second part, question number 4, 5 second part, 8 in your homework notebook. So your homework is from exercise 1.1, complete question 8 and 9 in your homework notebook. That will be entirely based on the properties of rational numbers which we have studied in the previous two lectures. And exercise 1.2, this homework will be related to these concepts which we have studied in this very lecture: representation of rational numbers on the number line and how to find out n rational numbers in the between two given rational numbers. Now let us discuss now the homework solutions of lecture number 2, that is exercise 1.1. Question number 1, I gave you second part as homework. Let us discuss about this question. Using appropriate properties, find. Now the question is, in this question we are supposed to use the properties, and let us discuss the properties in brief. First one is closure property, second one is commutative property, third one is associative property, and fourth one is distributive property. Closure property says that if I am adding, subtracting or multiplying any two rational numbers, then the result should be a rational number. This is your closure property. Commutative property says that if I am, suppose I am taking the example of addition, if I am adding two rational numbers like x plus y, then if I am changing the order of the rational numbers, then the result should be same. That should be equal to y plus x. Coming to associative property, if I am having three rational numbers like x plus y plus z in the bracket, then x plus y in the bracket plus z. Now on both these sides, in either of these sides, if I am changing the position of the bracket, then this particular property is known as associative property. Now next we have studied distributive property of multiplication over addition. In this case, I gave you the example also that if A multiplied by B plus C, then A is to be multiplied by B plus A is to be multiplied by C. Same is the case with distributive property of multiplication over subtraction. In that case, we will be using, instead of plus sign, I need to use the minus sign. Now, I hope all these properties are now clear to you. Let us come to question number 1, second part. The question is 2 by 5 into minus 3 by 7 minus 1 over 6 into 3 by 2 plus 1 over 14 into 2 by 5. First of all, out of these three terms, if a question of properties is to be solved, now in these types of questions, first of all we need to find out whether in any of these three terms, is there any rational number common out of any of these terms? Yes, definitely here in the first term and in the last term we will find that 2 by 5 is common. Now first of all you should be clear that 2 by 5 into minus 3 by 7, this is your first term, minus 1 over 6 into 3 by 2, this is your second term, plus 1 over 14 into 2 by 5, this is your third term. So now in the first term and the last term, 2 by 5 is common. So I am rearranging this third term along with the first term. Now what will be my step now? Step now 2 by 5 into minus 3 by 7 plus 1 over 14 into 2 by 5, and now the second term will be shifted at the end, that will be minus 1 over 6 into 3 by 2. Which property is this? Using commutative property we have rearranged, as I told you that if I am changing the position of the rational numbers, that particular property is known as commutative property. Now, coming to the next step, it is 2 by 5 into minus 3 over 7 plus 1 over 14. 2 by 5 from first and second term, we have taken 2 by 5 common. So, it will be 2 by 5 into minus 3 by 7 plus 1 over 14 minus 1 over 6 into 3 by 2 will remain as it is. Which property we have used here? Using distributive property, because where in the first step, this 2 by 5 into minus 3 by 7 plus 1 over 14 into 2 by 5. This is showing the right hand side of the distributive property of multiplication over addition, because 2 by 5 is being multiplied with minus 3 by 7 also, and 2 by 5 is being multiplied by 1 over 14 also. So next step will be 2 by 5 into, after taking the LCM of 7 and 14, it will be 14 definitely. So it will be minus 6 plus 1 divided by 14, minus third term will remain as it is, 1 over 6 into 3 by 2. Now 2 by 5 into minus 5 over 14 minus 1 over 4. Now after cancelling out the numbers, then I will be getting minus 1 over 7 minus 1 over 4, and taking the LCM of 7 and 4, that will be 28. So it will be minus 11 over 28. I hope all these steps are clear to you. I am repeating it. First step, first of all, look whether in which terms two rational numbers are common, rearrange those terms, and then after rearranging, apply the concept of distributive property like we have done in this question. Then after taking the LCMs and cancelling out the terms, you will be able to get the answer. Now, coming to next question, name the property under multiplication used in each of the following. The very first part is minus 4 over 5 into 1 is equal to 1 into minus 4 over 5 is equal to minus 4 over 5. In this case, as I am exchanging or interchanging the position of the rational numbers, 1 is definitely a rational number because 1 is an integer, that is the numerator is an integer, and denominator is also 1, that is again an integer. So 1 is an integer, rational number. So we know that in commutative property we interchange the position of the rational numbers. So in this case it is commutative property of multiplication. Now here in this part I also want to add that along with the commutative property of multiplication, we have studied about multiplicative identity. What is multiplicative identity of rational numbers? 1, as it was being told in the very first lecture. So here it can be multiplicative identity also. Okay, so this question has two answers, like commutative property of multiplication, or it can be multiplicative identity. Coming to second part, it is minus 13 over 17 into minus 2 over 7 is equal to minus 2 over 7 into minus 13 over 7. Again, the position of the rational numbers have been interchanged, so it is commutative property of multiplication. As multiplication sign is there, so it is a commutative property of multiplication. Now, coming to third part, it is minus 19 over 29 into 29 over minus 19. After solving these two rational numbers, my answer will be 1. So what is this property? Multiplicative inverse property. Okay, so I hope all these parts or the properties are very much clear to you now. Let us review it once again for this question number 5. It is minus 4 over 5 into 1 is equal to 1 into minus 4 over 5 is equal to minus 4 over 5. Here, as the position of the rational numbers has been interchanged, so it will be commutative property of multiplication, or it can be multiplicative identity also. Now, second part is minus 13 over 7 into minus 2 over 7 is equal to minus 2 over 7 into minus 13 over 7. So this is again interchanging of the rational numbers on both the sides. So it will be commutative property of multiplication. Coming to third part, it is minus 19 over 29 into 29 over minus 19, that is equal to 1. And we know that 1 is the multiplicative identity, and so this property is multiplicative inverse property.